Hi. You're the youngest crowd I've been talking to for about a year. So usually I stand in front of old, ugly men and tell them why not to be afraid of the cloud. So this might be different today. You already all heard of what the cloud is and what kind of the technology works like. So if I start to bore you, you can just shout boring, and I'm going to change it. And I'm a bit nervous today because today Sonia, my wife, is with me, and it's the first time she's seeing me talking in front of an audience in live. So be brave. I'm Nikolai. I'm on Twitter. The company is called Schnee von morgen. It's funny in German and intranslatable, so I won't. We're doing webTV for professional broadcasters. I'm a TV guy. I come from, I'm going to make this fast. I don't want to talk a lot about myself, but just to kind of, I did the first German web radio station when I was 17 years old. And afterwards, I worked for TV companies, mostly for Der Spiegel for 10 years. And kind of by accident, I got into project management of building up classical satellite dish TV stations. That's what I did for a long time. And in the end, I was a project manager for D-Max. It's this Munich, it's the German free TV Discovery channel, right? So, and then we started to concept and do the first internet video projects for Der Spiegel. And now we got a company that is about really kind of doing what TV is going, finding out what TV is going to be like in some years. That's kind of what we do today, right? And we did DCTP TV I think it's some years ago now, I think we launched 4 years ago, with Alexander Kluge. And it's nearly all German-speaking documentary channels. It's NZZ, it's Süddeutsche Zeitung, it's Spiegel TV, it's the BBC if it's in Germany, and Focus TV, and I don't know if we got to, I must have lost one. But it's all on this license model with Alexander Kluge. We won the LEAD Award in 2010. We do video management transcoding for tape TV. That's why their videos look so awesome. We launched Spiegel TV 2 years. I think it's second birthday some days ago. I don't need it now, but no, we haven't. Okay, no, I'm going to skip the audio part. And so I'm a TV guy. I'm not a technician. I'm not a software engineer. But by going that way, by kind of thinking about what films, movie content could be like if we push it to the internet, we had a huge stack of technical problems, right? And that's video transcoding, which is quite an amazing CPU problem, like you need lots of computers for doing that. And today we got thousands of computers doing that for us. You need to store a lot of content, and today we store even the broadcast version of the videos, so it's petabytes of storage we need. We need to deliver tons of content to people if they watch us, and that's what we hope for. So, and we need to manage everything and do statistics and things like that. And this is kind of the technical stack of the company today. We got, on average, 500 requests per second on static objects. We are in 3 data centers. That's an laser. We got 15 to 115 servers, if you might call it like that, on average. The data throughput is 4 gigabit per second on an average peak, so it's like every day. We got 6 apps in the app stores. We develop for these HBB TV, smart TV things. We use several cloud computing techniques to achieve what we do there. We do quite now, we invent new ad server techniques, and we host a lot of German video ad server content on our, and we do that's kind of posing. But we do prototypes for DAX companies right now, so it's a funny, small startup company. And I get asked often, how do we manage these big projects on our own hardware? And fact is, we don't, because all our property is in that cupboard. So we... So we earn nothing. And that's, this photo is 3 years old, I think, but this is the cupboard today. It's gotten bigger, but there are no servers in it. And this is the Berlin office. We're 8 people in Berlin, Hamburg, and Vienna, and 1 is on Tenerife now. So this is what it's... I don't know. In German, Reinhard Grebe said, "Wer Skype, der bleibt." It's... so it's... yeah, we're a Skype company. So we do everything in the cloud. We have no own server. The biggest server in our office is my Windows machine where I play computer games on when... yes. So, and then we got some laptops, and so, yeah, we need that technique. And today I'm talking about new rules when you develop for the cloud and do software for the cloud and how to achieve it. But before I'm talking about the new rules, they are kind of surrounded by uncertainty, doubt, and fear. That's what I normally talk about. And that's, I don't know if you heard about it. I heard that this thought, it's in English. I don't know if you know what it, Google it. It's in Wikipedia. It's really a communication tactic on breaking things. It's working with fear, uncertainty, and doubt. And that's what's going you, if you develop software for the cloud, welcome to that game. You're like, this is what's going to happen to you. So all the critics are going to talk about that. It's but you got no SLA, and the NSA is going to read everything we do, but it's boring. And so kind of this is day-to-day business. It is going to break. And it's the fear of not being able to control everything and losing something you've got today. So it's really it's mostly a problem about a mindset than a technology problem, but don't underestimate the mindset problem, because you're going to kind of be there every day. And from when I'm talking about TV, it's and I think it's the same with other businesses. But from TV, I can say that the TV business has been driven by content for all the years. So it was authors and editors that did great movies, and then said to the technical part of the company, we got to achieve it like that. Like we need a helicopter that does a great shot of that thing, right? And this completely changed until today. Today, everything is tech-driven, right? If you go to the web, and most technology decisions influence how the content looks like. E.g., movies got to be small or short. That's some years ago, right? Technicians said there's kind of a mark at 3 minutes. And actually, as I found out in my years, that was not so much a technology mark, that was technicians thinking that movies longer than 3 minutes might be boring for them. So they made technology gaps, they really influenced content, right? And that means today that they took control. And these are the people I usually talk to. And that's a huge problem, right? Because they build up a enterprise technology that if you want to do something new, you're going to fight against that one way or another. So this is your enemy, right? And he's going to fight you. And then infrastructure-wise, what he's been telling you for years is that he's building his own infrastructure, and it's cable porn, right? It's LED porn, and it's like, this is our data center. But as we all know, if you start up building something like that, in the end, it's that, right? And I planned some small data centers in my work life, and it's really like, I mean, it's not, but somewhere you open and you look and it's like, oh, no, gosh. And you find that, right? And it's, that's what he does. So he's afraid of you finding out that his IT technology is not cable porn, but chaos. So what I'm telling you is you got to take the power back and also take the infrastructure power back, because you need that if you want to reinvent everything, right? I got to see. Okay, there's a movie coming. I'm going to show this movie and make it as loud as possible.
There's a cable down there.
Really? There's a cable under the table. Here we go. Let's have a look. You got that? Right. Okay. I got to say something in front. This is a company, I don't know what they do. They are called Nebula. I just found out about them. They might be really nice guys. I used them in my presentation as an enemy since half a year, but I don't know anybody from them or of them, so it might be pretty much unfair what I do now. Because I think everything they do sounds like a piece of crap, but I'm not that sure, right? So they're called Nebula. It's not an... And I think they are a symbol for the old enterprise world inhaling the cloud and telling people they don't need to change anything. And IT, talking about infrastructure before had been the dream of that cable porn moment, like big rooms with thousands of LEDs and guys standing in the, right? So this is what they do, and it's really funny because they try to explain to people that the cloud computing we're using today is much more cable porn than it had been before, which is not, but listen to that movie.
2 years ago, a small group of scientists and engineers came together around one idea, that if the future of computing is in the cloud, that future should belong to everyone. What they would end up building was a kind of computer that would change everything. Introducing Nebula, the world's first cloud computer.
Okay, wait. See what they do, right? Basically, if you try to find out what this company does, is they are selling this thing in the middle. This is just glitter, right? And they're selling this thing, and it's an AMD machine with a dual-core one anything, and you're able to, as I understood it, you're able to host your cloud management thing locally. That's basically it, what they do. And they it's charged $100,000. And they go there and they do this cable porn movies, and they are telling the IT guys that that everything's going to be okay. We take your computers, we throw them away, but we give you back better LEDs. That's that's what that thing, right? Let's see where that brings us. Okay, it's not getting better. Oh, sorry. I need to do that joke. So if you in terms of cloud computing, most enterprise operators, like business guys, they go to their old computer guys and say, we've got new problems that we want to solve. How are we going to achieve it? And the old guys can't help anymore because, you know, this is ugly guy from before, right? He's on cable porn. So you got to achieve something new, right? And the main problem with doing something new is that you go there with preconceived ideas. You think you need something before you do something, and that is so wrong. In terms of cloud computing, I'm quite radical, but I think you take all your like SLAs and all your support documents and all the guarantees you got, and you take all your cable pawn LEDs and all the knowledge you got before, and even the language you've been talking before, like in terms of computer language or anything, and you take your quality standards from today, and you throw them all away. This is what you're going to do. And if you talk to the cloud guys, to the enterprise guys, it's really like the first thing they tell you is that, have you got an SLA, and can we sign that, and where are our guarantees? But the cloud works so radically different that the first thing you're going to do is free your mind from all those ideas. It's going to be brilliant, but this is kind of the rubbish you gotta throw away, and then you start there. It's really a white piece of paper, or yellow in that case, I think. But it's empty, that's the important part. And because the cloud is technology-wise such a big opportunity and so different from what the perspective of what you're going to do, that you're going to ruin everything if you go there with your preconceived ideas, right? If you if your business today is about hosting 25 servers that do your anything, right? You might go to the cloud just by renting 25 virtual machines on Amazon and pushing your applications there. And then you achieved nothing, right? It might even get more expensive. Or not. So what you're going to do is start from the beginning and say, okay, we want to decouple everything. Usually you're sitting on a big pile of legacy code, right? Today, like you got this one huge application that is doing your problems on every day. So like you're throwing it away and you're starting from, okay, we got tons of small problems, and you solve those problems in services. And you're going to see that most of the services you need are there, because those problems are not only your problems, but thousands of people in the world got them. Most of those services are even done by the cloud vendors themselves, right? You need a NoSQL database that is scaling until infinity. That problem is solved for you. No reason to host that on your own, right? And you're going to start by writing tests. That's how we achieve it. There are other ways of developing software. It's just that ours is best. You're going to test everything and write tests against your own services, which brings you in a different, I think my talk is called It's Going to Break, which it is. So the software you are going to write is going to break. The more often, the better, right? Because in the old IT world, everybody was talking about buying bigger computers, right? It's like in the end, I think I bought a 16 or 32 core machine. I'm not sure. But it's really like we had this one problem and we were throwing RAM and CPUs against that problem, and it got bigger and bigger and more expensive. And in the end, we had this spaceship that solved the problem for us, right? But if the spaceship breaks, it's broken, right? So in the old world, everybody is about getting unbreakable hardware and writing unbreakable software, because it shall not break. And in terms of hardware, you were always like redundant everything. You were throwing tons of money against redundant everything, right? And in terms of software, you were like putting hell of work to achieve that. I mean, we're talking about JBoss, Java server, things that shall not break, right? And today, with cloud computing, the infrastructure and the software world totally changed, because what you want to do today is do something chaotic, yeah, right? You want to have small services being completely decoupled of each other. You want to be able to switch between those services, and those not via backups, but via fallback mechanisms, or even via load balancing mechanisms, right? So in terms of your services or instances, it's like small is bigger than large, right? The smaller you get this, the more decoupled you get this, the better it is. And in this situation, I mean, with my company, we are like, on a normal day, we start, I don't know, let's say 2,500 servers, like all around the day. Most of them are only running for some hours. That's an average day, right? And I would say that round about 5% of them do something wrong, right? They got startup problems. They got no correct route to the point where we want to point them, right? Or the route to the audience if they are streaming servers, so they are not able to reach them. Or there are millions of things that could go wrong. So what we do is we're not putting that much energy in tuning those last 5% of errors. Actually, we encourage our developers to produce more errors, right? But where we put our energy is in software that detects those faults, right? So we write engines that run on those instances that try to find out what goes wrong with oneself, right? And then it's much more a computer social task on finding out what goes out with the people next to you, right? It's like everybody does that. And so we play that tell me something funny about your table game all the time, right? The instances sitting next to each other, and they want to find out stories about each other. And if they find out something's broken, they just take it out of the system and even kill it if they want to, right? It's radical, and start something new. And that whole system scales in like by the number of 1 in 100 inside a day, right? And it's doing huge tasks for us. So the scalability is awesome, and the fault tolerance of those systems is much bigger than the systems you're used to do. So in terms of database, because if you're writing services, that's usually kind of one of the first problems you got. NoSQL is better than SQL, right? So because NoSQL is so stupid, right? You're able to build, like if you don't want to use a NoSQL, I don't know even if the name database is right there, you can also go to key value stores and store them on on files on a disk and put them on somewhere. So your fallback mechanisms in working with the data are so cool, and nobody in this room knows how to repair a MySQL database. And we all find out how to do that when it breaks. And we use MySQL, and not only MySQL, we use relational databases in two of our software. One is our WordPress block, right? And the other, I'm not sure. And this is really the only component in all of our hardware that breaks constantly. It's the WordPress block of our company. This is kind of the last thing that I spent in the last year 100 hours fixing our WordPress block, right? Scanning MySQL, rebuilding index, fuck you. Okay, in terms of I always said that more is more than less, and failover is always better than having a backup. That's also great because in old story from me, how are we in time? Where are we? Is something, I don't want to talk all day. 50 minutes left? Okay. I was working for Spiegel TV. We did build up a new TV station called XXP. It's some years ago. It's a documentary thing. And the software you need to program a TV station, like first this movie and then the other one, it's quite expensive and stupid. So I started writing that on my own, and I did it in Lotus script, in Lotus Notes. So I wrote, it's really my first software thing, I wrote a Lotus script database that was actually controlling the TV station. It was kind of playing the movies, right? And we are not talking about digitally playing, but it was controlling the tape recorders, the broadcast tape recorders. It worked for 6 years. Okay, and for that, we bought one server, and the Lotus Notes was running on that server, and I had no clue on what to do. And I said, but I need it redundant and cheap. And so we had a server with 2 hard drives. That was the redundancy. And people told me, if one breaks, the other is going to, right, okay. And I knew nothing about it. I just bought it and put it there, and the Lotus Notes database controlled the, I'm not sure if I'm allowed to tell that, but it really did, for years. Okay, and then we saw the TV station, and the hardware was kind of going down, but that server still did his job. And on the last day I went there, and I was like, okay, now it's the great moment to find out if he really does. So I put a hard drive and I took it out of that computer. And the computer went out and it never ever go on again. It just broke in that moment. And since that day, every time somebody is telling me about a failover or fallback mechanism, first thing I do is break that thing and see if it does what he tells me, right? If you're buying hard drives and somebody's telling you you're even able to take out 3 of them before you said take out 3, like that moment. You go there and you take out 3 hard drives, right? And then you flip out this one, it's Netzteil in German. What is it in English? Power supply. Like, if it's redundant, you take out 1, right? And then this is really like, this is what we do today. And this is what we do today with software. So we want software that breaks. Okay, this is kind of the end. It's in terms of new software for the cloud, I think agility is much more than control. You are going to lose control or a certain amount of virtual control you thought you had about your software before. But you gain the opportunity to collect data and to react on that data. So before you might have had the impression that your piece of code is something you are able to control fully because you wrote it. I don't know if you ever read code that is 3 years old. I don't control my source code. Sometimes I got comments in my own code that I read and they sound like from a different spaceship. I don't recall it. It's like, I found an old source code, a comment that is like, I know it's ugly, I tested it, it works, leave it untouched. And that note was to myself, because at that moment I knew that nobody else is going to read it. So this was kind of a wormhole note. It's like, I saw the future, leave it untouched. So your virtual control you got today over your source code is worth nothing, right? But you're able to collect data on your software, and perhaps you don't do it today. So you test everything. And by everything, I mean, that's why we hire crazy people, because crazy people are awesome in testing crazy things, right? Because the first thing you're going to do if you write tests is test your software against what it should do. But if you're an average programmer, I mean, I believe you that the software does that. I will never test that, right? If your job was to write a software that stores something in a database, it's quite an ugly moment if you give me that software and it even doesn't do that, right? But I want to know how your software reacts if we do something crazy, right? Like in terms of our video transcoders, the first thing that went wrong when they were in the wild is that people were trying to transcode Word documents with them. Because they kind of, in the input queue, they throw the Word documents describing the metadata of the movie. And that broke pretty much a lot, right? So we haven't tested against that. So you need crazy people to find out what goes wrong. And people are more worth than machines. And by that, I mean mostly like, you really gotta, I know so many companies where people sit and do the same legacy tasks every day. And there must be somebody doing a decision that their machines are much more worthy than the people. Because machines could do that with only 20 watt of power, like for thousands of years, but they hire people that go there every day and say, oh, it's broken again. Yeah, we know. There's this beggar. Yeah, I started now. Yeah, come back in an hour. And then tons of people do jobs like that every day, right? And you don't want that. You don't want to have problems with your old stuff. You only want problems with your new stuff. So, so if in my company, there's only one moment where I get angry on people, and that's when they're not telling me that something went wrong, right? If something goes wrong, the job of everybody is to be transparent with what they know, right? And then we collect the data. And then first, I mean, if it's production urgent and everything's on fire, then first thing we're going to do is fix that problem, of course. But if not, pretty much, in most cases, first thing we do is to write a test against that problem, that it won't ever happen again. Right? So there happened a fault that we haven't thought about in our tests. Right? Our crazy people weren't crazy enough to think of what happened there. So first thing we do is kind of to formalize that craziness that just happened and test all our software against that in the future. So this thing that went wrong will never happen to us again. Right? And last thing is, ideas are worth nothing. So that's kind of my major claim. There's so many people claiming that, there's so many Berlin startups, right, full of ideas. And so that's why you're all here today. Go out and do it, right? If you've done something, that's worth something. Thinking is worth nothing. Don't kind of hang your ideas too high. Go and do it. Right?